Alright, today you're going to talk about the polyatomic ions and how to name and write their formulas. There are many polyatomic ions. However, you will only use a handful of them most of the time. So I will provide this handout to you as a resource at the beginning of each unit so you can refer back to them to help you. So polyatomic ions are named based on their non-metal or metal that makes them up. Notice it seems like an awful lot of them contain oxygen. They don't always. There are some that don't contain oxygen. There are many others besides just these. So if you look at ammonium, it is not to be confused with ammonia, which is NH3, and that's a neutral compound. This is a cation consisting of 4 hydrogens and a nitrogen with a +1 oxidation number. So when you write formulas and write names of polyatomics, you include the oxidation numbers to indicate that that's a ion and not a neutral compound. Okay, because normally neutral compounds are always written without the superscript. Acetate, which is the same thing as when it combines with hydrogen, forms acidic acid called acetic acid of vinegar, which is what you put on your foods or you pickle things with. So acetate is 2 carbons, 3 hydrogens, 2 oxygens, and has a -1 charge. Notice cyanide, you've probably heard of this before, it's poisonous. And then you can have hydrocyanic acid, which contains hydrogen with carbon nitrogen. This does not contain an oxygen. So cyanide is just carbon and nitrogen, triple bonded with a -1 charge. Hydroxide is a oxygen hydrogen with a -1 charge. Unlike its name, try to remember it's not HO, like as in what Santa Claus says, ho, 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 but it's OH. So it's hydroxide. They just write the name this way. Permanganate is manganese with 4 oxygens with a -1 charge. Then you have the 2 variations of the nitrogen polyatomic ions. One's called nitrate and one's called nitrite. So they both have the same oxidation number. The variation is the number of oxygens. So 8s have more oxygens than ites. Ites have just 2 oxygens. All right? All right. So let's look at the bromine group. We've got bromate, like bro, with 3 oxygens. It's an 8. Notice per is 1 more oxygen than an 8. And then ite, remember, is 1 less than an 8, 1 less oxygen. And then hypo is 1 less oxygen than an ite. So as you learn these, if you'll just remember what the basic ones are, the 8s, and then remember what the prefix and suffixes mean, and that tells you how many oxygens. Because nothing else changes. Ooh, I left off a -1 there, sorry. Nothing else changes with their oxidation numbers. It's just the oxygens that change. Okay, so the same naming conventions can be applied to the chlorine polyatomic ions. Chlorate happens to have 3, and then per is 1 more, and then ite is 1 less, and then hypoite is 1 less than an ite. And then iodate has 3, and then per has 1 more, and then 1 less is ite, and then 1 less than ite is a hypoiodite. And then this is called bicarbonate or hydrogen carbonate, okay, because carbonate is CO3 with a -2 oxidation. So notice most of these so far have all been -1. Then we move into the -2s. Carbonate is the only one by itself except for hydrogen carbonate, which is bicarbonate. So if you probably heard of sodium bicarbonate, that's baking soda. All right, so we got vinegar and we got baking soda, and what happens when we put the 2 together? We make bubbles. It's because you make a chemical reaction. It's because this is kind of like a base and that's kind of an acid. So, all right, and then we've got chromate and dichromate. Notice it's a metal covalently bonded with oxygens. Chromium, some of the transition metals can form covalent bonds. So this is unique for these elements, and it's because they have half-filled d orbitals. Notice it's 4 instead of 3 with the 8, but di has 2 chromiums and 7, and then both are -2. And then these two are very common. We use these a lot. And notice the 8 here is a 4, and then ite is a 3, and then but the 8 is a 4, and then ite is a 3. So notice that the sulfate, sulfite, and phosphate, phosphite, we eliminate the and the or here. However, when we start naming these again, we add that extra syllable. You'll see that later, because these are used to make names for acids. And then naming gets changed as we go through when we talk about nomenclature. Okay? So, and that's all for this particular day. Talk to you later.